All right, here we go. We're going to do one more video. We're going to take a look at the law of cosines one more time. One of my favorite parts of math is that no longer how long you study, you have still cool things that you can learn. And I had actually been teaching this particular class for many, many years. I mean, it's kind of embarrassing to say it, but probably 15 years that I taught this class before I even realized that this particular technique that I'm going to show you right here even works. Usually when you have a solution, we just tend to stick with that solution and get it. So every single time that I saw an angle side triangle, I use the approach through law of sines. And I never even really thought about using law of cosines as a way to approach it until one day I just kind of looked at it and thought, I wonder what happens when I try that. And whoa, that's really, really cool. So we're going to take a look at that. Now, there's a little bit of a hint here because I think you've seen a problem set, a kind of problem before where sometimes you get one solution, sometimes you get two solutions, and sometimes you don't get a solution. I think there's a kind of problem that you saw in Math 2 and Algebra 2 that sometimes had no solution at all, sometimes had one, and sometimes two. Sounds a lot like a quadratic to me. Sometimes the parabola never hit the axis, sometimes it hit once, and sometimes it hit two. I mean, that happened. So we're going to take a look at looking at this problem using the law of cosines. So I'm going to try to do this with relative speed. So here's the deal. Let's take a look at a problem where the measure of angle A is 27 degrees, that the side A is 19 inches, and that side C is, let's say, 12 inches. Okay. Now, I'm going to go ahead and draw a quick picture up here, and I'm going to say that A here is 27, side A is 19, and I guess this would be C usually is how I've done it, and I'm going to put B down here at 12. Now, here's what's going to happen. The hint right here is this is definitely angle side, which I'm going to go ahead and write it this way. But we definitely have that ambiguous case. So we know that there's that possibility of two triangles, one triangle or none, but I'm not sure what. But the key is that I handed you A right here. So I'm going to go with this version of the law of cosines because specifically this thing talks about angle A. 2bc cosine A. So we're going to substitute in everything we know. We know what A squared is. 19 squared is 361. Equals B squared, but I don't even know what B is. That's my big question. Plus C squared. Well, C squared was 144 minus 2 times B, I don't know it, times C, which was 12, times the cosine of 27. Well, 2 times 12 times the cosine of 27 is just a number with a b attached to it. So let's see. What I've got is the following. And 2 times b times 2 times 12 times the cosine of 27, according to my calculator, is actually negative 21.384b. And to get this to 21.384, oh, I did it again. I did B4. It should be 4B. 384, 21.384B. I think I'm dyslexic a little bit. So anyway, 2 times 12 times the cosine of 27 makes that happen. Well, notice that we've got a B squared and we got a B. So I'm going to go ahead and do one more little thing, which is to resort this information. I'm going to forget the 4 for now. I'm going to bring that 361 to the other side, which is going to give me 217. Now, this is really, really strange. This looks like a quadratic, doesn't it? Something x squared minus something x minus something. So I have a quadratic equation solver on my calculator that I'm going to use real quick. And so remember, A was the coefficient in front of that squared term. B was the coefficient in front of that normal term with the first degree, and C is the part out here at the end. And so when I put all of that stuff in, what I got is that the possible values of B by the quadratic formula are 28.891, or it could be negative 7.511. Well, clearly there is no way I can have a triangle that has a negative side length. So that's crazy. So B doesn't have two options, it has one. Now I could put that up here at 28.891. But what you're going to see now is that I can now use the law of sines to finish, because I could then say that the sine of 27 over 19 would be the same as the sine of angle B down here to 28.891. And little quick cross multiplication, a little bit of solve, and we're going to be able to go get that thing. Or in fact, the smarter play would have been to use the sine of C over 12. In fact, that's what I should have done, because this one could have been obtuse. And that would have messed me up a little bit, because 28 is a very large angle. So I think I want to go with this one. But the point being, I'm not going to finish that because we've already done the law of sines. But this clearly has one triangle. There's only one way, and I can tell that because when I went to find the side, I got one positive and one negative. So let's tweak that a little teeny bit. I think it's going to be fairly obvious how this works, but I don't want to assume anything. So let's take a look at the measure of angle C being 38 degrees. Side B is 23 and side C is 18. Now, since this is mentioning specifically angle C, let's do that again. Here's C, this 38 degrees. Side C is 18. I usually put B over here and A over here. Notice side angle again. But since it mentions C, I'm going to go with the C version of the quadratic formula and the law of cosines. So we're going to go with C squared, C being 18, so that's 324, equals A squared, which I don't know what A is, but I know that B is 23, so 23 squared is 529, minus 2AC would be negative 46 times A times the cosine of C, which we knew to be 38. We're just going to go ahead and do a little quick rearrangement of that, because 46 times the cosine of 38 is 36.248. And we still have that A attached. And of course, I should bring this 324 across because we like quadratics to be set equal to 0. So if I bring that across, I get 205. And now we can go back and we can grab my program here, and remember A isn't the A that we see from here. A is from the quadratic formula, leading coefficient of 1, then a secondary coefficient of 36.248, and a tertiary of 205. And now notice that I have two numbers, 29.2 and 7.0. So I've got A is 29.236, or maybe A is 7.01. Well, those are both good numbers, aren't they? Those seem reasonable in terms of what happens. So we do have an option 1. And then I could use the law of sines to finish, because I have a side and an opposite angle, and I would go sine of 38 over 18 equals the sine of beta, or B, over 23. Notice I went with the 23, not the 29, just in case something turned out to be obtuse. And then we have the secondary option over here, where maybe, just maybe, in fact, not even maybe this time, it definitely happened. It's going to be good that this value of A might have been 7.012, so we could play the same game, that the sine of 38 is to 18 as the sine of A is to 7.017. Clearly, that's a small angle, so the law of sines won't struggle. So we have two triangles that time. Now, I did one problem where we had one triangle. I did one problem where there was two triangles, which leads us to the last option that sometimes we don't have any. And so my example for none is pretty quick. Obviously, if there's no solution at all, it's probably going to pop pretty quick. And so this is what I came up with. So notice that since, that's funny, I forgot to put the A there. So measure of angle A is 40 degrees. I wrote that very poorly, but whatever. So angle A right here is 40 degrees. That side is there. I got a 22 here. This is my favorite configuration. So again, since A is the one that is mentioned, I'm going to go with A squared equals B squared plus C squared minus 2BC cosine of A. And there we go. A squared equals B squared. Well, B squared is huge. Plus C squared. I don't know what C is. Minus 2 times B times C times the cosine of 44. Oh my goodness. Now, doing a little bit of quick rearrangement, I have C squared minus 33.706C, just the same thing I've done in the previous examples, plus 435 is 0. Now, if I grab my handy dandy calculator here and I ask, hey calculator, can you run this one more time? And let's make the leading coefficient there 1. Let's make the second coefficient 33.706. And let's make the last one 435. Oh my gosh, it's telling me we have complex roots. This thing never happens. That means there is no solution for C, and if C cannot be found, then that means that there was no triangle. And so you can use the law of cosines to not only solve for none, 1 or 2. So you can just trust the quadratic formula to do the talking, and you don't have to worry about the swinging sides that you see in law of sines. It's not visual. We lose that side of the coin, but it is actually very predictable, and it's very, very fast if you have a little program set up in your calculator to do the law, to do the quadratic formula. So hey, that's a lot of videos from me for today. I'm out. I hope that was helpful.